Good afternoon, everyone. Konnichiwa. Um, our presentation in English. So our topic is Auto-Kensha. Basically, it's a service for end-to-end on-demand emergency vehicle for the people in need. Today presentation, we have three contents: why we need Auto-Kensha, our services, and our business model. Here is me and from my friend Nicholas. So for more details, you can refer our LinkedIn ID. So before starting, we have know why we need Auto-Kensha and what is Auto-Kensha. So here you see these days there was a depending increase of ambulance in every country. So as you see, the ambulance use is expected to increase as a basic. Thus, the time taken by patient to hospital is also increasing. That is one of the potential factor we want to consider. So our model, Auto-Kensha, has faster arrival time and the motto to save more lives. Here is the data about ambulance call out and the time taken to arrive to call out. And you can see there was a significant increase by day of uses. And the second reason is about potential danger of human emotions. Basically, you can see this news that elderly driver died after had a collision with ambulance. So during emergency, our relatives or the members try to force the driver to drive faster, which may collapse human emotion and cause fatal accidents. And the third, that is most prominent, that we have difficulties in finding hospitals. When the ambulance arrives, the driver has needs to consult like available beds, equipped or specialized doctor is available for that patient or not. And this was currently method in Japan to call an ambulance, and which is quite inefficient to calling, because if you are in emergency and you need to give answer for all these steps like medical emergency, your address, and communicate symptoms of patient to the speaker, and also you have to say the patient age and have to wait. So it will take potentially more time to arrive the ambulance. And if we save this time, it's better to provide more good hospitalization to the people so that we can save his life. So we have find and do study that currently national average for ambulance time in Japan is 8.9 minutes, and national average time for hospital admission is 40.6 minutes. On the basis of this study, we find very interesting that on the basis of US data, if the ambulance arrive greater than 8 minutes, it can possibly cause 7.1% death. And if less than 8 minutes, then it is 6.4% death. So it was data in Tokyo in 2016. The number of ambulance call is 777,000 cases. And if we calculate with the current demand, which is 8.9 minutes, it can call potentially 55,000 people to death. But if we reduce the time, we can have 49,000, which is, if we difference with this images, you can see potentially we can save 5,442 people a year, which is quite a significant number. And saving lives is not only to giving good life, but it's also help to GDP, to gross domestic product. So in Japan, we calculate one person is value like 5.4 million. So based on our previous slide, you can calculate that if we save this much of people every year, we can also do GDP of around 29.6 billion approx. After this, our services will follow by Nicholas.
So now I will explain about the service that is provided by Auto-Kensha. So here we propose several values, and the values will be sorted from the one with the highest priority to the one with the lowest priority. So here we want to provide faster aid so that we can save more lives in the process. And secondly, we want to automatically find the appropriate hospital based on the patient's condition. Thirdly, we want to reduce travel time by automatically reserving intersection and safe interaction with pedestrian for safe and fast travel to the hospital. And finally, because we are using autonomous technology, we make sure that our system is not affected by stress and emotional conditions. For our customer segments, we want to focus on two customers respectively, which are government bodies for operations inside of Japan and insurance companies for operations outside of Japan, because ambulances are managed privately in foreign countries. And here I will explain about the step-by-step of Auto-Kensha. Firstly, we can either call Auto-Kensha manually using an application, which is as convenient as using an Uber by simply pressing a button, or Auto-Kensha could be automatically called using a health monitoring system in smartwatch, for the example. And for these two systems, they can send coordinates to our server so that Auto-Kensha can travel as fast as possible while ensuring safety to the patient's location. And inside of the ambulance, there will be an emergency worker inside that will actually take into account the patient information, such as injuries and symptoms and so on and so forth. And after correlating this information with hospital information, then we can find the nearest appropriate hospital so that the most optimum route could be computed to that hospital location. And then during its travel from the patient's location to the hospital, then it will be assisted by pedestrian management and intersection management for safe travel. And finally, Auto-Kensha will arrive at the hospital proper. And our added feature is that we have demand-based allocation of Auto-Kensha. So that the number of Auto-Kensha or automated ambulance in one area will be adjusted based on the number of historical demands that exist in that particular area. And the goal here is to achieve faster response time based on the number of demands in one area. We also have automatic reservation of intersection for Auto-Kensha so that intersection can be automatically reserved by Auto-Kensha. And in this case, our Auto-Kensha can communicate with RSU or roadside unit so that the traffic light could be automatically turned green for approaching Auto-Kensha. Meanwhile, HMI could convey the intention of Auto-Kensha to pedestrian, so pedestrian could know when they need to cross the crossing safely. For our business model, we divide into operations inside Japan and outside of Japan. For in operations inside of Japan, we'll partner ourselves with government bodies. And in this case, patients do not need to pay directly to our companies, but instead pay by proxy through these government bodies. So in this case, by patients paying the national health insurance premium, then it will be some of the income from national health insurance premium will be allocated for our operations and deployment. Secondly, for operations outside of Japan, we'll partner ourselves with insurance companies. So in this case, our ambulance could be added as exclusive benefits in the insurance packages offered by these companies. So in this case, patients also do not need to pay directly to our companies, but by proxy through these insurance companies. For our cost structure, we'll focus only on Tokyo region for now, for our trial. And in this case, we can expect an initial expenditure, CapEx, or capital expenditure of approximately $1.86 billion that we can estimate by summing all of these expense components, such as the self-driving software, salary for engineering team, and so on and so forth. And if we omit the initial procurement cost, then we can obtain the operating expenditure of approximately $1.74 billion for the following years after deployment. For our profit estimation, we will obtain profit or income from the usage fee of Auto-Kensha. So here we will charge for each number of cases in 1 year. So assuming there are 777,000 cases in 1 year in Tokyo, and if we charge 3,500 yen for each case, then we can obtain approximately 2.7 billion yen for our gross income. And by computing all of these, we can expect an initial profit of 0.86 billion yen and an operating profit in the following years after deployment as 0.98 billion yen. But these numbers are nothing compared to the number of lives that we can save in Japan. And in Tokyo alone, we can save 5,442 people based on our estimation. And in terms of contributions to economy, that will be equal to 29.6 billion yen. So that's all from our team, and we hope that our service can provide great contribution to society. And